It's my pleasure now to invite CE10 co-organizer and founder of For Good Ventures, David Welch, up for his closing remarks to get us ready for what needs to come from here. David.
Neil, great. I got a couple slides. I'm going to try utilize to talk through some of the commentary here, and let me see if I can get this to share. Neil, thank you very much. Huge thank you to all the speakers yesterday and today. My energy level around this is just continues to amp up because the information, the insight, the wisdom that was presented so far at this conference has just been spectacular, and I really thank everybody for that. I'm here because I'm one of the founders of For Good Ventures. We are a community of entrepreneurs that are really out there looking to solve a number of global challenges, of which green global warming gas reduction is a key aspect of it. One of the things that I wanted to touch on, which is a uniform statement and really amplified today, is this concept of systems and systems engineering. You know, Arun mentioned yesterday, we need to think differently to connect the dots between industries. And what's that mean? And if you look at your energy system as it exists today, well, I have multiple systems, right? I got a transportation system. I got a guy who pulls out oil, refines it to gasoline, distributes it through a variety of mechanisms. We have our, it's interesting, Sally used the word storage, but her, in that context, storage are tanks, where I am storing the fuel for energy. Or I have a transportation network. That network is predominantly disconnected from the grid network. That's a completely unique, different network that has a variety of energy sources on there. It's also disconnected from the industrial gas network, which is an independent network. So our energy systems now, and part of the problem of those energy systems now, is that there's multiple systems. And they don't connect together. They don't meet in the marketplace. They don't meet in the technological space. So today, the emphasis has been on systems. And you have to think about, from a systems, what do I want to do? I want a common energy marketplace. I want a place where I can enter and exit with energy. And as a result, I will have multiple forms of energy that come onto that marketplace. And that is going to ultimately drive simultaneously resiliency, reliability, scale, and cost reduction, right? That's what marketplaces do. That marketplace is called our grid. And another repetitive commentary, I'll highlight Steve's comment yesterday. Make no mistake, the world is heading towards electrification. That comment is exactly the convergence of our energy systems towards a predominantly electrified network. Electrification, that grid, that entrance and exit off of a common distribution network is key, because what that does is it now puts all the energy sources on a common playing ground, right? Of which the issues of reliability, resiliency, cost structure, scale are all part of that. If I can get everything to integrate onto that grid and onto that distribution network, I will realize simultaneously the value of the user experience, the customer's benefits, cost, reliability, resiliency, and it will prove in the ability to drive towards a sustainable renewable energy, because sustainable renewable energies have a variable cost that is inherently less than the variable cost of things that consume things. You don't consume anything in a sustainable energy source. You're consuming sunlight, you're consuming wind, but those things are delivered to you for free. The other systems are consuming coal, they're consuming natural gas. There is an actual raw consumption of the material, and as a result, the variable costs are higher. Creating the ecosystem around that common trading place will create the most rapid ability to transition our energy networks. That rapid is a key aspect. And Jerry highlighted this. See how you move my, there you go. Humanity is at a crossroads and time is running out. Take this as a call of action, not a call of despair. But I do want to highlight the sense of urgency. Urgency is critical in the evaluation of how we go about that. And you have to architect a system that is capable of responding urgently. And that has to do with the movement towards a common distribution infrastructure. If I had as much that needs to go on in many sectors, and I'm a government, the most important dollars that I can spend, I believe, are about ensuring that that common infrastructure that can absorb multiple different types of energy and redistribute that, whether those are local sources or large distributed sources, that is the key enabling element that's going to drive the adoption of high reliability, low cost, clean energy into our system. Make sure that you've figured out how to create the grid or the marketplace to easily accept new technologies, including fusion on there. So now I jumped to a slide that really was the the apex of all of our discussions here, and that is the transformation of this energy system as represented by the Sankey diagram. Today, about 20% of the energy onto that source is carbon-free or non-carbon, and 80% is carbon-based. Over the next couple of days, we're going to have to rewire this diagram and be realistic about economic transitions. If I want to achieve 50% carbon reduction, well, to first order, I've got to take out 40% market share from the carbon, and I got to move that 40% market share to the non-carbon side. That is a massive economic lift. What we've also talked about is the movement of transportation from a petroleum sourced energy to moving it towards the electrical grid. That is also a major lift. But on this chart, what it shows us is the way we've laid out our energy system today actually throws 60% of our energy away. There's reason for hope and reason that we can move to a system that reduces this rejected energy substantially by reconfiguring both our sources and our uses of energy in order to come out with a dramatically reduced wasted energy and ultimately a dramatically reduced carbon emissions from that. So, excuse me. So what do we got? We've got a very rich technology portfolio to pull from, much of which has been talked about today. That ranges from our existing energy sources all the way to new sources like fusion, or we talked a little bit about hydrogen over the last 2 days. But there's a number of things that have to come with those sources. I'm gonna throw out my asks of the industry, and I am sure they're incomplete, but I throw them out there to be a little bit provocative, frankly. What do we need to get to 2030? Focus 2030. We have lots of solutions that we can further consider for 2050, but focus on 2030 for right now. What do we need? We need all of our end uses efficiencies to improve. That's a great general comment, but quite honestly, it's true. We have so much low-hanging fruit, from leaf blowers to better refrigerators in there. We need to push, and government needs to set standards that drive better energy efficiency. We need to move to an electrification network, which we've talked about that. I don't know what we can actually achieve, but I think a target of 50% of our transportation moves to the grid-based infrastructure is a very aggressive goal to achieve, and I think that's something that we should formulate for. We need to think about our energy sources. I'm going to make two comments here, and this is more in response from what I've heard over the last few days. Is Solar and wind, it's great. We're going to have to get that to scale. I don't think we should consider solar and wind unless solar and wind brings with it storage, right? I need to buy a solar panel that has storage. I need to buy a wind generator that has storage. It has to be part of an element that is system-based. The system needs to put energy sources on there that can flatten out their profile on their own, because that's effectively what the cost structure is. And I'm going to challenge the industry that storage, it's not 2-hour storage that can be done with lithium. It's hundreds or maybe 1,000-hour storage that needs to be accommodated with those sources. In that area, then you can truly start to equate your different energy sources in that process. And that challenge to the industry is that we've talked a lot about the use of lithium battery technology, which is fantastic for things that have high energy density requirements. We need a different storage element, which is low cost at massive scale. We need to change our grid conversion efficiency. We didn't talk about it today, but as I understand it, the conversion of fuel to electricity, it shows up in the Sankey diagram. It's really only about 35% efficient. And that is because we still use some generators that we ask to ramp up and ramp down in power capabilities, which takes them out of their design efficiency spot. If I tell a grid element to maintain constant power, I can achieve much greater efficiency. Well, that's the same problem that happens in a hybrid fuel vehicle. Let the conversion element operate at the highest point of efficiency, and then use effectively capacitive elements, batteries, in order to mitigate disbursement of that energy. Net, we need the electric conversion efficiency to increase at least 15 points. And I make the point that carbon energy needs batteries also, because the efficiency for a constant output generator is much greater than the efficiency of a variable output generator. Run it at its highest efficiency point, build batteries in to mitigate the demand cycle, drive to a net grid conversion efficiency increase from that. It's clear we're going to have elements, and it was brought up by many speakers. Natural gas seems to be the evolution here, which is great. We need a demand from our natural gas, two things. It needs to come equipped with a certain amount of carbon capture associated with it, and it needs to certify that there are no leaks in the supply of natural gas into the system. And that has to be a baseline requirement for us to equate that. If they can achieve that, well, then the natural gas and the solar and wind are highly competitive with each other, and we'll see which one is economically drives to the outcome. But they need to, the industry needs to validate, certify that they can achieve that and achieve a minimal carbon footprint from that element. Although many reports still propagate coal, as long as we can create natural gas substantially cleaner, we need to eliminate coal from the system. So those are my personal challenges to these, and I think they add up to helping to push along. The hard part is less the technology. The technology is obviously critical. The hard part is the speed of economic transformation. We underestimate this. We think that I can take a multi-trillion-dollar industry and move it from one organization to another organization quickly. It doesn't happen. And so therefore I have to, it's key to get a marketplace that will accept energy from any provider and put demands on each provider to make sure all their energy sources are effectively clean from a carbon perspective. And government's role is to minimize the time in transition to allow that speed through that economic transition to go quicker. And that means certification. That means they need to incentivize the marketplace. They need to eliminate adoption barriers, eliminate deployment costs, and the certification of technologies, whether it's deployment of windmills, the advancement of the grid structure, the adoption of dispersed batteries throughout the grid, et cetera. They need to figure out how the barriers of certification and adoption are reduced. If you can do that, then the conversion of the economic system can go much faster. Create a healthy competitive landscape, utilize the common marketplace of the grid to filter out, naturally filter out energy sources that are most attuned to both our economic and our environmental needs from that. Burden those that hurt either of those economic or environmental needs with the appropriate costs associated with that. This is actually more of a political statement. We won't be able to achieve this unless we simultaneously support an overall healthy economy. We need to, in order for the environmental outcomes to surface to the priority of the citizens, we have to simultaneously ensure there's a healthy economy around to support those. Okay, there's a sense of urgency, and this is where when I review the inputs from everybody, I think we're missing something. What is the definition of a catastrophe? And I know this is a hard conversation to have, and I don't mean to be I approach this from a systems engineer, not from a fatalist perspective. We're doing this because human society is at risk of catastrophic outcomes. We market this as a scientific number, 1.5 degrees or 2 degrees, but really what we're trying to project is the trauma that our societies are at risk of. Whether it is rising seas, fires, the number of displaced humans that are at risk because of these environmental outcomes are truly the things that we need to monitor and we need to metric ourselves by. There is a sense of urgency because the number of displaced people continues to increase every year. It's a consequence of weather extremes, and we're soon to compound that with global environmental ecosystems shutting down. We need to know when we have to solve it in some short-term different fashion. We need to have a vehicle, and if we can't change our carbon emission patterns or we can't capture enough carbon at appropriate cost, we need to figure out another alternative that preserves the Earth's stability and the human society stability while we figure it out. I'm going to throw this up here strictly to be provocative. It is guaranteed not to be the truth, but this is what we need to look at. Today, this is my personal take of from the Sankey diagram where we are in 2021, and I threw some numbers in there. And again, please use this as a vehicle to say, no, you're wrong. This number should be different. These are proper. These are what I would call reasonable market share transitions from 21 to 2030 to 2050. And it is my personal best guess. I would hope that there are far more intelligent people that can use this as a format to go in and say, no, you're wrong. This is possible. This is what will be achieved. Because the market share will end up at a certain point, and it's not going to end up at our aspirational goals at 2050. It's going to end up somewhere in the middle, but we still have to achieve our carbon reduction goals. Otherwise, we will see a rapid increase in human trauma. I throw this out there. Of course, in my mind, the course over the next couple of days is to argue a chart that looks like this and argue what are the things that have to happen to meet the needs of the carbon reduction, to avoid the trauma that society is going to go through, and that is realistic about what the distribution of the various market shares are. With that, I want to thank you. Feel free to reach out to me at the contact information there. Neil, this has been an absolutely a wonderful program. Again, I thank the speakers, and I'll hand it back off to you.
Great, thank you, Dave. Thank you for wrapping us up and sort of pulling all the pieces from the last couple of days together. Really appreciate all of our attendees being here and listening to all these great talks and putting such thoughtful questions forward in the chat. I'm sorry that we only got a chance to hear from a small number of them. Just so anybody that is curious can hear this, the video from today and yesterday's talks will be publicly available on the CE10 website later this summer. We're hoping by the end of June. The CE10 organizers, David and Bert and Harry, have put together a working group that's going to meet in a sort of workshop format for the next couple of days. And they'll be developing a white paper on this path to a 50% cut in emissions over the next 10 years that will be publicly available and widely disseminated when it is finished. So again, thank you all for joining us, and go out, enjoy the rest of your days, and hopefully enjoy them while making choices that reduce your impact on the climate. Thank you all.